Hello student, did you have a question for me?
Yes, Professor Urlacher, I did. I was confused because in class you told us that for our paper we should measure relationships between two continuous variables.
Yes. I did say that, in class.
I know that a continuous variable is something that you can count in a way that has mathematical meaning.
Yes.
So a state's life expectancy or gross domestic product per person would both be continuous variables.
Yes.
But how would I measure a relationship? There are 193 countries and I simply cannot find any pattern when I look at that many cases.
Yes. Any attempt to keep track of that many cases will hurt your head. You should not try to do it.
So what do I do?
Well, if you think the relationship between two continuous variables is linear, you could use Pearson's correlation coefficient. Do you think that?
I have no idea what you are talking about. I just want to write this paper.
Oh, well, perhaps we should look at this pattern I have drawn on the board.
Wait, I have seen this kind of graph before.
Yes, this is a scatter plot with gross domestic product per person on the horizontal axis and life expectancy on the vertical axis. The data is from the Gapminder website.
I can see a clear pattern in this graph. It looks like the points kind of follow a line that slopes up from left to right.
Yes, this is a positive linear relationship. When we plot cases on a graph, we see a pattern that kind of looks like a line that either slants up or down.
Oh, so when you asked if the relationship was linear, you were asking if I thought there was a pattern that looked something like this?
Yes. That is what I was asking.
So if I think my variables have a linear pattern, I still do not know how to measure it.
Well, you could simply show a graph like the one on the board, but there are more precise mathematical ways to describe a relationship between two variables.
Is that the Pearson's correlation coefficient you were talking about?
Yes. That is what I was talking about.
Oh. I kind of stared at you like you had gone insane, but now I see that you were actually trying to help.
Yes.
So what is the correlation coefficient?
Pearson's correlation coefficient is a way to describe a relationship between two variables. It takes two variables, puts them on the same scale, and then measures how close the pattern between them is. If two variables have no discernible linear pattern, then the correlation coefficient will be 0. If two variables are in perfect sync, the correlation coefficient will be either -1 or +1. Most of the time the number will be somewhere in between.
Oh, that sounds really useful. If the correlation coefficient is 0.8, that means the relationship is closer to perfect than if the value is 0.4.
Yes, with a value of 0.8 we would say that the relationship's if very strong. We would describe the relationship as moderately strong with a value of 0.4.
But why is the number sometimes negative? Wouldn't a negative number mean an even weaker relationship than a value of 0?
Well, not every relationship is positive. If we look at the board again, you will see that sometimes the pattern can run in a different direction.
Wait, what are we looking at now?
On the vertical axis we now have child mortality. As states become wealthier, child mortality is less common.
Oh, so as we go from left to right on the horizontal axis, the trend starts high but ends up low.
Yes, this is a negative relationship. When the correlation coefficient is negative, it tells us that the pattern looks something like this pattern on the board.
I see. The correlation coefficient tells us not only how strong a relationship is but also the direction of that relationship.
Pretty much.
So all I have to do is report the correlation coefficient and people who have studied statistics will know what the relationship looks like.
Now you see why correlation is at the core of most statistical techniques.
Wow. Correlation is awesome.
You might even say that it is wicked awesome.
No. No, I don't think anyone would actually say that.
Oh,